Hi guys! Ang unang lesson natin for this playlist is all about the finite difference method. So ano ba tong method na to? Sige, simulan na natin ang discussion. Palitan ko lang ng laser point no, para visible tong point. So according dito, the numerical value of the derivative of the function can be obtained by finite difference method, no? So, gagamitin pala natin tong approach na to kung gusto mong hanapin yung derivative. And when we say derivative, tandaan nyo to, hindi lang tayo nakalimit sa first derivative. Pwede natin hanapin yung second, third, fourth. Actually, yung i-discuss ko sa lesson na to is hanggang sixth derivative. Although, hindi na ako nagbigay ng example nun kasi hindi na siya practical, no? So, basahin ko na lang to. This can be done using three approach: forward, backward, or central methods. For simplicity, the formulas for approximating the first and second derivative of the function is provided without providing a proof. So, ito yung formulas for the forward finite difference formulas, no? Considering second order accuracy. So, ang nakikita nyo ngayon is the first derivative, pero yung second derivative niya is this one, diba? So, first and second derivative. Hindi ko naman to pinapamemorize sa inyo, and actually, hindi ko rin naman gagamitin itong formulas na to sa module. If you want to see the proof of this formulas class, dinerive ito using the Taylor series. But again, hindi ko naman na siya gagamitin kasi kung makikita nyo sa module nyo, I assume hawak nyo siya ngayon, pwede natin gamitin yung naka-attach na table doon. Mas maganda yung table. Basta tandaan nyo lang na for forward, naka-second order accuracy tayo. Napaka-importante ng order of accuracy ngayon dito. So, second order ang forward. Proceed tayo for the forward, backward finite difference. Again, second order accuracy siya, and these are the formulas. And lastly, for the central finite difference, using the fourth order accuracy, so ito naman yon. Again, wag nyo nang intindihin tong mga formula na to. Ang gagamitin natin itong table na to. So, basahin ko lang, likewise, a tabular presentation of the coefficient of f of xo plus or minus nh is shown to determine the first to fourth derivative of the function. So, dito muna tayo sa forward finite difference using the second order accuracy. So, bakit siya tinawag na forward? Kung titingnan nyo tong coefficient, f of x sub o, tapos yung sumunod is f of x sub o plus h. So, fa-forward siya at a regular interval h. So, yung h natin, again, that is the regular interval. Then, f of x sub o plus 2h, f of x sub o plus 3h, f of x sub o plus 4h, and f of x sub o plus 5h. So, dito naman, first, second, third, and fourth. So, these numerical values will be the coefficients na, again, mas maintindihan nyo when we provide an example. So, the same table is for backward finite difference. Kaya naman na siya natawag na backward kasi f of x sub o, pa-backward siya. F of x sub o minus h, pa-backward. F of x sub o minus 2h, pa-backward ulit. F of x sub o minus 3h, so pabawas naman, kaya backward siya. And these are for first, second, third, and fourth. And lastly, for the central finite difference, ito mas mataas yung accuracy niya, fourth order. Ibig sabihin, kung central ang gagamitin nyo daw, mas accurate yung makukuha nyong approximation. Yun lang yung ibig sabihin ng order of accuracy. Pero dito, di ba, naka-central siya. Balance siya kung titingnan nyo. F of x sub o minus 3h, f of x sub o minus 2h, f of x sub o minus h, f of x sub o, f of x sub o plus h, f of x sub 2 plus 2h, and f of x sub o plus 3h. So, balance siya. Kaya nga siya tinawag na central finite difference. Again, pakita ko lang yung inyong module. So, ito yung forward, backward, and central. Sige, mag-provide tayo ng isang example para mas maintindihan nyo itong topic na to. Basahin ko lang siya ngayon dito. Example, determine the value of the first and second derivatives of the function shown below at x is equal to 3. So, yung function natin is f of x is equal to 5 cosine 3x minus e raised to negative 1/2 of x. Letter A, using the analytical method. Letter B, using the forward finite difference method. Letter C, using the backward finite difference method. And letter D, using the central finite difference method. For the finite difference methods daw, yung interval natin na h is 0.20. Hint, no? Wag natin i-ignore ito. For the purpose of accuracy, the initial and final answers daw must be expressed in 6 decimal places. Sige, simulan na natin na isolve itong problem na to. Solution for analytical. When we say analytical solution, this is the exact solution. And yes, paano ko mahahanap yung eksaktong first saka eksaktong second derivative? Ang gagawin nyo lang is gamitin mo yung natutunan mo sa calculus, which is the rules of differentiation. So, eksaktong ganun ang gagawin nyo. Again, for this method, obtain the first and second derivative of the function using the rules of differentiation. So, for the first derivative, by the way, hindi ko na i-discuss yung mga rules na yon kasi nga I assume na pagdaanan nyo na yan doon sa calculus ninyo. Numerical method is an advanced mathematics subject. So, syempre, yung calculus diba is considered as basic mathematics pa yon. Kaya, before kayo mag-advanced mathematics, magbe-basic math muna kayo. Nevertheless, ito yung computation ko ng first derivative. You may just check this na lang using the rules of differentiation. Pero confident naman ako na yung first derivative ko is negative 15 sine of 3x plus 1/2 e ng negative 1/2 of x. Since yung x natin ay equal sa 3, so common sense, isubstitute nyo lang yung 3 natin dito sa first derivative. Yun lang ang gagawin. Just substitute x is equal to 3 dito sa first derivative. But, wag nyong kalimutan, dapat po yung calculator nyo ay naka-radian. Karamihan kasi dito, akala nila basta naka-degrees, itatype lang yung sagot, okay na. No. Dapat po, ang calculator is naka-radian kasi diba meron tayong trigonometric function dito. So, dapat iset nyo muna siya as radian. Di ko alam kasi iba-iba yung mga calculators natin na ginagamit. So, refer na lang kayo doon sa manual ng calculator nyo kung paano iset sa radian ang respective calcul nyo. Gayunman, pwede na tayong mag-proceed for the second derivative. Again, I just use the rules of differentiation, and according to my calculation, ang second derivative is this one, negative 45 cosine 3x minus 1/4 e raised to negative 1/2 of x. The rule is the same, just substitute x is equal to 3 here. So, f double prime of 3 is negative 45 cosine of 3 times 3 minus 1/4 e raised to negative 1/2 ng 3. So, 40.94579. Same rule, dapat naka-radian ang calculators nyo. Sige, simulan na natin using the forward finite difference. So, for the forward finite difference, isolve muna natin yung f of x sub o to f of x sub o plus 3h. At x sub o equals 3 and h is 0.2. Bakit hanggang dito lang? Ito yung another concern nyo, no? Bakit hanggang f of x sub o plus 3h lang? This time, punta na tayo doon sa table. Mas maganda kung ipakita ko na lang siya. Kung titingnan nyo for the finite difference for forward method, ang concern lang naman natin, di ba, is the first and second derivative. So, kung titingnan nyo sa first derivative, hanggang ito lang, oh. Hanggang f of x sub o plus 2h. Dito wala na siyang coefficient. And for the second derivative is hanggang dito lang. So, ito wala na siyang coefficient. So, syempre, for practical reasons, ito lang na 4 ang hahanapin mo from f of x sub o to f of x sub o plus 3h. I hope that is clear to all of you. So, balik na tayo sa PowerPoint. Yun lang naman ang gagawin nyo. And of course, balik ka lang sa simple substitution, guys. Kasi, di ba, ang gagawin nyo dito is to substitute the given from the original function. So, di ba, ano nga yung original function natin? F of x is equal to wait lang. Medyo makakalimutin ako eh. That is equal to 5 cosine 3x plus o minus e raised to negative 1/2 ng x. Basta wag nyong kalimutan na dapat nga again, yung calcu is set on radian. So, ang gawin nyo lang, halimbawa, remember na ang x sub o is 3 and yung h is 0.2. So, yung una is f of 3. Tapos, yung h is just an regular interval. So, 3 to 3.2. So, kasi x sub o plus h is 3.2. So, 3.4 and 3.6. And yung mga values na yan, isa-substitute nyo lang siya dito. So, pwede nyong i-pause muna tong video na to para masiguro nyong tama itong mga calculation na to. However, bigyan kita ng technique sa calculator. Di ko alam kung ano yung hawak nyong calculator, pero kung yung hawak nyo is this one, itong Casio na calculator ngayon, pwede natin siya computein ngayon kasi kayang mag-generate ng table nitong Casio na to. Pero kung hindi mo alam to, okay lang kasi ang concept lang naman is just substitute 3 to 3.6 to the given function. Pero kung gusto nyo ng shortcut, so mode lang, hanapin nyo lang yung table. I think lahat ng calculator may table, pero yung purpose is hanapin mo yung table. So, i-type mo yung f of x. By the way, before that, i-make sure nyo lang na naka-radian yung calculator ko. So, mag-pop-up display nga muna ako. Ito siya. Sa calculator ko, naka-radian na siya. Okay? Pero, para mahanap ko siya ng dire-diretso, ang gawin nyo is 5 cosine 3x. Literal lang na i-type nyo yung calculator. Minus e raised to negative 1/2 ng x. O, ayan na. Na-type mo na siya. Tapos, yung start, magsimula ka sa 3. Matatapos sa 3.6, di ba? From 3 to 3.6. Tapos, yung step is yung value ng h, 0.2. So, ayan na siya. Ba't may syntax error? Negative lang yung na-type ko. Dapat negative 1/2. Sorry. Ayan. Same lang yan. So, tadan! O, di ba? From 3. Tingnan nyo tong malaking screen dito. O, 3, yung value niya is negative 4.778781. O, scroll down mo lang. O, negative 5.125336. Tapos dito, negative 3.754012. And for 3.6, negative 1.136948. O, diba? At least hindi ka na magpapagod kakaisa-isa nun, no? So, I hope this simple technique, no, can help you. So, applicable to sa may mga ganitong calculator. Pero ang general rule is, for as long as yung calculator nyo is may table function, kayang-kaya nyo na yun sundan. So, I think pwede na kung bumalik doon sa PowerPoint presentation. So, dito sa baba, ang nakasabi na lang is, use the tabular presentation of the coefficient to solve for the first and second derivative of the function. So, i-flash ko na to. Exit nga ulit ako. No, ito na yung formulas natin for the first and second derivative of the function, no. So, gusto ko i-emphasize nyo dito o tumutok kayo dito sa formula na to. Okay, gusto ko tumutok kayo dyan muna for the first derivative. At the same time, kasi ituturo ko na sa inyo kung paano gamitin yung table eh. Tingnan nyo tong table na to. Forward finite difference tayo or forward finite, first derivative. Yung f of x sub o is negative 3/2. Tapos, yung f of x sub o plus h is positive 2. Yung f of x sub o plus 2h is negative 1/2. Sana natatandaan nyo. Tingnan nyo to ngayon. Ang first derivative, palagi nyo munang i-divide ng 1 over h. Yun yung general rule. 1 over h yan pag first derivative. Pag second derivative is 1 over h squared. So, balik muna tayo sa first derivative. 1 over h. Negative 3 halves ng f of x sub o. Bakit yun negative 3 halves? Kasi tingnan nyo, f of x sub o, negative 3 halves. So, anong ina-expect yung second part ng function? Siyempre, plus 2 ng f of x sub o plus h, which is, tama siya. O, plus 2 ng f of x sub o plus h. And diba, dito sa last, negative 1 half siya ng f of x sub o plus 2h. Tingnan nyo to. So, negative 1 half ng f of x sub o plus 2h. So, diba, hindi mo na kailangan i-memorize yung ibang formula. For as long as may table ka, masosolve mo to. So, paano ko naman dinerive itong second derivative before ko to i-proceed So, pag second derivative, ang una palagi is 1 over h squared muna. Again, kung first derivative is 1 over h, yung second derivative is 1 over h squared. Tingnan mo ulit yung table for the second derivative. Yung f of x sub o, di ba ang coefficient niya is 2? So, dapat 2f of x sub o. Eh, ayun siya. 2 of f of x sub o siya. So, tama ulit siya. Then, next tayo, negative 5. Tapos, f of x sub o plus h. Balik ka dito sa PowerPoint. Negative 5 ulit siya ng f of x sub o plus h. Tingnan natin yung sunod. Positive 4 ng f of x sub o plus 2h. So, yun, di ba? Positive 4 ng f of x sub o plus 2h. And lastly, dito, negative 1 ng f of x sub o plus 3h. So, syempre, minus f of x sub o plus 3h. So, di ba? Gamit lang yung table na derive natin yun. Kaya nga to finite difference. Then go back to the to this slide kasi nahanap mo na yung f of x sub o, f of x sub o plus h, f of x sub o plus 2h, and f of x sub o plus 3h. So after nyong ma-establish yung mga formula, isa-substitute nyo na lang yung mga numerical values niya. So ganun lang ang gagawin nyo. Sana malinaw tayo doon, di ba? So say, i-discuss ko na siya formally kasi at least alam na natin kung paano ma-derive yung mga formulas, no? Using the table. And ganun din yung concept para sa backward tapos sa central. Ganun din yon. For as long as may table ka, tingnan mo lang yung coefficient doon. Anyway, for the computation, flash ko na siya. Diniscuss ko na kung paano na-derive tong formula. From the previous slide, yung f of x sub o is negative 4.778781. Pasiguro na lang na 6 decimal places kasi nga 'di ba, yun yung nakalagay sa instruction ng problem, 6 decimal places. Tapos 2, negative 5.125336, tapos ito, negative 3.754012. Computin nyo na lang siya, tapos pwede nyo muna ngang i-pause itong video for a while para ma-make sure yung tama. Pero ang lalabas is negative 6.027473. Ayun siya. For the second derivative, flash ko na rin siya. O, ayan lang yan. Just substitute. Hayaan nyo muna yun mag-substitute kasi diba, this is an approximation. Huwag kang mag-alala. Alam ko sa analytical solution ang layo nitong 54. Kasi diba kanina sa analytical, at least 40 siya. Pero hayaan nyo lang. Mag-compute ka lang. Okay? So, just substitute the given values, no? So, sana clear tayo doon. So, negative also for the second derivative, that is 54.750 for 50. So, ito yung process kung gagamitin nyo is the forward finite difference method. How about mag-backward ka? So, for the backward finite difference, ito naman na siya. So, solve for the values of this time from f of x sub o minus 3h to f of x sub o. Again, yung formula natin is f of x is equal to 5, yata yon, tama ba? Yes, 5 cosine 3x minus e raised to negative 1 half of x. Ito yung original function natin eh. So, pero since backward, balik ka ulit doon sa ating table. So, first and second derivative, ang i-consider lang natin ito kasi hanggang second derivative hanggang f of x sub o. So, yun lang yung hahanapin nyo. And, pwede pwede nga itong gamitin ulit ng calculator nyo eh. I-AC ko lang. Same function, i-type mo lang tong same function. But this time, alam mo, magsisimula sa f of x sub o plus 3h, that is, type mo lang 2.4, tapos yung end is 3. Yung interval ulit is 0.2. Kung sakaling tinatamad ka mag-substitute isa-isa, i-calculate nyo na lang. So, for 2.4, 2.740, 562. For 2.6, ayan siya, pero pwede natin yan i-shift eng para lumabas na naka-decimal. So, negative 0.002755, and dito naman, negative 2.843040, and 3 is negative 4.778781. So, gamitin natin yung backward finite difference formula sa pag-solve nito. So, yung next slide natin is ito. For the first derivative, tandaan nyo, 1 over h yan. For the second derivative, 1 over h squared. So, tingnan ulit natin yung table for the backward. Magsisimula siya sa first, ang coefficient is 1/2. So, 1/2 daw nitong f of x sub o minus 2h. So, tingnan nyo, 1/2 ng f of x sub o minus 2h siya. Tapos, susundan ng negative 2 ng f of x sub o plus h o minus h. So, minus 2 ng f of x sub o minus h. And yung katapusan is 3/2 ng f of x sub o. So, ito siya. Plus 3/2 ng f of x sub o. So, sana clear tayo doon. For the second derivative, simulan nyo muna siya sa 1 over h squared. And as you can see here, nagsimula siya sa negative 1. So, f of x sub o minus 3h. So, iyon siya. Negative ng f of x sub o minus 3h. Tapos, plus 4 ng f of x sub o minus 2h. So, ito siya. So, sana malinaw tayo doon ha. Then, again, minus 5 siya. Tingnan nga natin, no? Yes, kasi negative 5 ng ito, negative 5 ng f of x sub o minus h. So, yun. And lastly, positive 2. Tingnan natin. So, positive 2 ng f of x sub o. So, at least nagagamit na natin yung table. Hindi mo na kailangan mag-memorize ng formula again. So, ipagbibigay tiwala ko na lang sa inyo tong numerical calculation. Just substitute yung mga values dito na nakuha. Ayan lang naman siya, diba? And, mahanap nyo na yung first and second derivative. Alam kong malayo-layo ito compared sa analytical solution. Pero hayaan nyo na. Nasa exploration pa lang naman tayo nitong finite difference method. Okay? So, i-pause nyo muna tong video na to. Central na to eh. I-pause nyo muna to, no? Tapos, tingnan nyo kung tama itong numerical calculations ko. Pero feeling ko naman tama ito. Proceed na tayo sa central finite difference, no? Tapos na tayo sa forward, tapos na tayo sa backward. Ito naman yung central. So, same process. This time, balikan natin tong table. Bakit f ng x sub o minus 2h hanggang f ng x sub o plus 2h la yung gagamitin pagdating sa central. Kasi 'di ba, ito yung table ng central. First and second derivatives ang concern natin. So, simula dito hanggang dito. Lahat yan, no? Itong first and second derivative, no? So, that's very clear. Ngayon, pwede mo ulit gamitin kasi from f of x sub o minus 2h to f of x sub o plus 2h, from 2.6 to 3.4. So, kung gusto mong mag-shortcut, gamitin nyo na lang to. Walang problema dyan. AC lang. Dati na kasing nakatype yung function ko. Pero, pwede nyo naman siyang i-type o. Halimbawa, i-retype mo lang 5 cosine ng 3x. Basta wag nyong kalimutan na dapat naka-read dyan ang calculator nyo e raised to negative 1/2 ng x. O, magi-start sa 2.6. Matatapos sa 3.4. Ang step is yung h 0.2. So, for 2.6, kung ganyan, click nyo lang tong shift eng dalawang beses. So, lalabas na siya as decimal. Okay? For 2, ito. So, check natin kung pare-parehas. Yes, tama siya. So, good. Wala tayong problema sa calculation. So, use the tabular presentation again of the coefficient to solve for the first and second derivative of the function. So, yung central, ito na yung formulas niya. And again, we can check that, no? Wait lang. We can check the values, class, using this table. Halimbawa, for the first derivative of the central, dito, 1/12 siya ng f of x o minus 2h. So, 1/12. By the way, huwag niyong kalimutan 1/h yan. Tapos, negative 2/3 to. So, negative 2/3. Kung mapapansin nyo, wala na siyang f of x sub o kasi from the table itself, yung x sub o is 0. Dito, no need na siya. And punta ka na sa 2/3 nitong f of x sub o plus h. So, di ba, naging biglang positive 2/3. And lastly, minus 1/12 ng f of x sub o plus 2h. So, ito na yung value. Di ba? For the second derivative, derive ko na rin. 1/h squared siya. So, yun yung una. Tapos, this time, negative 1/12. Kaya, negative 1/12 ng f of x sub o minus 2h. Then, plus 4/3 ng f of x sub o minus h. This time, may coefficient yung f of x sub o that is negative 5/2. So, minus 5/2 siya, nun. Then, plus 4/3 ng, ito naman, plus 4/3. So, yun, plus 4/3 ng f of x sub o plus h. And lastly, minus 1/12 ng f of x sub o plus 2h. So, once kasi, diba, na na-establish mo na tong formulas, ang gagawin nyo na lang naman dito, class, is to substitute these values na na-obtain natin. So, madali lang, in general, itong solution natin. So, ipagbibigay tiwala ko na lang yan sa inyo, no? Halimbawa, ito, substitute mo na lang, substitute nyo na lang, substitute nyo na lang. So, ang mahahanap natin na first derivative is negative 6.044630. And yung second derivative is 40.887877. Among sa three formulas natin, ito na yung tandaan nyo, no? Among doon sa forward, central, o forward, backward, and central, si central, yung pinakamalapit doon sa analytical. Remember na itong analytical solution natin, siya yung eksakto. Kasi ginamit mo talaga yung rules ng calculus, di ba? So, for the first derivative, negative 6.070212. For the second derivative is 40.945079. If we are going to compare that in the central, napakalapit. Of course, may error yan. Hindi mawawala yung error kasi approximation. But still, compared to the forward and backward, yung central ang nagbigay ng pinakamalapit na approximation. So, proceed na tayo dito nang matapos na tong video na to. As shown in the previous example nga, itong diniscuss ko, the central finite difference gives the nearest approximation of the first and second derivative of the function. Yung computation ng relative error, 0.42% lang yung error ng first derivative and 0.14% yung error ng second derivative. So, as shown in the table below, so this table. The main reason of its accuracy is the formulas provided for the central are established for fourth order accuracy. So, napaka-importante nun, di ba? Naka-establish kasi yung central finite according to the fourth order accuracy, unlike in the forward and backward na naka-second order. Kaya mas accurate siya. By the way, ang computation ng relative error, syempre, approximation minus exact over exact. So, for the forward, yung first, niya is 0.7%. So, di ba, accepted pa yung 0.7. But yung second derivative, kasi yung na-compute natin doon is 54.75 something eh. Pero yung exacto is 40.945. Ang layo. 33.72 ang error. Sobrang layo nun. For the backward, ang lalaki din ng error. So, yung central, less than 1%. So, ibig sabihin, napaka-liit lang nung error natin using the central. Kaya nga karamihan ng programmers, ang ginagamit naman talaga is the central finite difference method. Kasi siya yung magbibigay ng accurate na solution. So, tingnan nyo yung error is 0.42 and 0.14. Ang layo nila compared dito kay forward and backward. However, yung ibang engineers and scientists, ayaw ng ganitong error, guys. No? Ayaw nila ng napakalaking error. Bakit? Kasi sometimes unacceptable yan. Dapat nga 0.001% lang. Oo, minsan may mga ganong engineers and scientists na gusto nila accurate na accurate yung numerical solution. So, paano natin mai improve? Yung tanong natin ngayon is paano natin mai improve yung accuracy ng solution natin? Kasi that is part of the problem in the numerical analysis. Tandaan nyo, lahat ng solution natin dito ay approximation. The question now is, paano natin may improve yung accuracy ng solution natin? According dito, yun na nga, as I said, for some reasons, the relative error of the solution may be unacceptable for some engineers and scientists. So, in order to improve the accuracy of the result, the following recommendations can be used. So, halimbawa, yung una, the values of this is expressed in more decimal places. Ngayon, ang ginamit lang natin ay 6 decimal places. Pero kung gusto nyo ng mas accurate, edi gawin mong 8 or 10 decimal places. Ganun lang yon. Okay? Yung method 2 is yung value ng h, dapat i-express mo siya into smaller values. Halimbawa, yung h kasi natin ngayon is 0.2. Pwede naman yata na yung h is mas maliit, 0.1 or 0.01. Ganun yon. Ganun yung gustong concept ni stage 2. And yung 3 is yung gagamit tayo ng mas accurate na finite difference formula. So, the first and second recommendation can be a problem if hand calculation will be used due to the human error. Ibig sabihin nito, minsan, dahil sa, alimbawa, nakaligtaan mo lang or namalikmata ka, human error yon, namamali tayo sa computation dito. Lalo na kung ang rine-require sa inyo is isulat nyo siya in 10 decimal places or yung h is sobrang liit, pwede kang mamalikmata. Pero, sabi dito, this is not a problem if the calculation will be performed by computers due to its storage power. Halimbawa, an Excel file can store the value of a single number for 30 decimal places. So, yung Excel hanggang 30 decimal siya. Yung Python, 15 decimal yon. That itself, marami-rami na yan. So, yun yung kailangan yung tandaan doon. Kaya, kung Excel ang gagamitin, mas programming lang, medium, hindi ka mamumroblema sa method 1 and 2. Kasi pwede mo lang i-edit na 0.001 itong h. Hindi ka magkakaproblema doon. So, ganun yung concept dito. For the third reason, meron kasi tayong third recommendation, use a more accurate formula. The more accurate formula for the central finite difference will be discussed after nitong video na to. Kasi 'di ba napag-usapan lang natin yung central finite difference is accurate lang to the fourth order. Bakit may mas mataas pa bang order of accuracy? Let's say 6th order or 8th order. Ang sagot is yes. And ano yung mga formulas na yon, malalaman nyo sa next video. So, i-end na natin to dahil napakahaba na ng video na to. Thank you so much for listening and watching, and I hope naintindihan nyo itong unang part ng discussion natin. So, bye-bye!